We're going to start with a scene that, on the surface, looks like a technical quarrel about gravity, and underneath is a duel over what you're allowed to say about God, causation, and how the universe holds together. Welcome back to Premise Hunting Through History. In this episode, we're not chasing a symmetry baked into a field equation or a single adjective, mathematical, in a definition of time. We're hunting something even slipperier. A silence, a refusal to answer. 3 words in Latin, hypotheses non fingo. The famous I frame no hypotheses. Those 3 words have been canonized as the motto of scientific modesty. Newton, we are told, was the good empiricist. He wrote down the law of universal gravitation, calculated the orbits, matched the data, and then virtuously refused to speculate about the cause. That's the story. But if you look at the actual debate Newton was in and the way Leibniz pressed him, those 3 words look less like modesty and more like a man evading with as much honesty allowable without revealing the hidden hypotheses behind hypotheses non fingo. So, let's set the stage. By the time the Principia is out in the world, one thing is clear. Newton's mathematics work. Planets move where he says they should. The moon's orbit fits. Tides, comets, falling bodies, all come under a single law. Each body attracts every other in proportion to their masses, and inversely as the square of the distance between them. That is a staggering unification. One equation binds the apple and the moon. But in the late 17th century, if you did natural philosophy, you didn't just have to get the numbers right. You had to play by the metaphysical rules of the mechanical philosophy. Those rules were brutal in their simplicity. 1. Bodies only act where they touch. 2. All causes are pushes and pulls transmitted by contact. 3. No spooky influences across empty space. Everything else was dismissed as occult qualities, scholastic ghosts that the new science was supposed to exorcise. Against that background, Leibniz formulates a very sharp dilemma for Newton. Either gravity is real or it is not. The trap pivot is twofold because if gravity is real, if it is something in nature that genuinely causes bodies to accelerate, then, given Newton's own equations, that something is operating across empty space, with no medium, no mechanism, no chain of pushes and pulls. One lump of matter over here, another over there, and somehow, across the void, they tug on each other. This is action at a distance. But the whole point of the mechanical philosophy was that this sort of thing was unintelligible. Not just, we don't know the details yet, but in principle, unacceptable. To say one body directly attracts another through a vacuum just by virtue of its mass was to smuggle back in the very occult qualities everyone had spent decades trying to eliminate. So if Newton says, gravity is real, it looks like he's committed to an absurdity. On the other hand, if Newton wants to avoid this, he can say, no, you misunderstand me. Gravity isn't real in that sense. It's just a mathematical device, a way of summarizing how bodies move, not a genuine cause in nature. In that case, gravity becomes a bookkeeping trick. Like a Coriolis force you invent in a rotating frame, useful for calculation, but not something out there doing any work. The real causes would have to be some other properly mechanical process, vortices in an ether, subtle streams of particles, something that pushes and pulls in a respectable way. But then Newton loses the very thing that made his theory revolutionary. He hasn't discovered the cause of anything. He has just found a clever way of fitting curves. That is the dilemma Leibniz keeps thrusting under Newton's nose. If gravity is a real cause, you are committed to action at a distance, which is unintelligible and unmechanical. But if you reject action at a distance, gravity is not a real cause, and you haven't explained the phenomena at all. 2 horns, no easy escape. Now look at how Newton speaks in his own text. All through the Principia, he doesn't treat gravity as a mere accounting trick. He speaks as if gravity truly acts on bodies. He identifies the force that keeps the moon in orbit with the force that makes stones fall. He calls gravity a vis, a force that causes departures from inertial motion. He is not shy, mathematically, about treating gravity as a real term on the right-hand side of F equals ma. At the same time, in his private correspondence, he is absolutely explicit that the idea of bodies somehow directly reaching across empty space to pull on each other, with nothing in between, is for him an absurdity no competent thinker should fall into. So we have a tension in that Newton talks like someone who thinks gravity is a real, causally efficacious force. Yet Newton also insists that action at a distance, with no intermediary, is philosophically incoherent. Leibniz notices this. He is too sharp not to, and he keeps poking with what is this attraction? Is it a real force or just a name for what happens? If it is real, how does it operate? Through what medium? By what intelligible mechanism? Or is it, as I suspect, an occult quality decorated with equations? This is not a friendly inquiry. It's a cross-examination. It's at this point that we get the famous line. Confronted with the demand to say what causes gravity, Newton writes in the General Scholium and in related correspondence, "I have not been able to discover the cause of these properties of gravity, and I frame no hypotheses." On the standard reading, this is Newton being appropriately hard-nosed with an insistent, "I derive the law from phenomena. I don't speculate beyond the data. I refuse to posit invisible mechanisms just to soothe philosophers. Hypotheses about causes are not the business of my mathematical philosophy." It's a very flattering picture. Newton as proto-positivist. Newton as the first great anti-metaphysical physicist, content with prediction and reticent about ontology. But that picture does not sit comfortably with the rest of his life. This is the man who wrote millions of words on theology, prophecy, church history, alchemy. The man who dug into the metaphysics of space and time in De Gravitatione and Tempus et Locus. The man for whom natural philosophy was inseparable from questions about God, substance, and causation. Does this really sound like someone who had no view about what gravity was, or is something else going on? Imagine you are Newton. You have built a stunning, mathematically precise theory that explains the motions of the heavens and the fall of bodies with a single law. You are convinced, on deep philosophical and theological grounds, that there is a real cause of these motions, that you are not just playing with symbols. You think you understand, at least in outline, why bodies attract each other. But you also know that if you say out loud what you actually think that cause is, you walk straight into two minefields at once. You either violate the mechanical philosopher's taboo against non-contact causation, or you expose a theology that, in your time and place, counts as heresy. Now you are being publicly pressed by one of the sharpest minds in Europe, a man who is, in his own way, fighting for a very different vision of God and nature. He is trying to force you into either admitting an absurd physics or confessing a suspect metaphysics. What do? You do not lie. Newton, whatever his flaws, is not in the habit of straightforwardly denying what he believes. But you also cannot tell the whole truth, so you split the difference. You assert again and again that gravity truly exists, that it suffices to account for the motions, that the phenomena follow from gravity alone according to the laws you have discovered. You take your stand on the mathematics and the empirical success. And when the question comes, yes, but what is this gravity? Through what does it act? How are we to understand it? You refuse to answer. Or you do answer with, "I frame no hypotheses," not, "There is no cause," not, "Gravity is merely mathematical fiction," but also not, "The cause is X." Silence in exactly the crucial place. This series is called Premise Hunting Through History for a reason. In the Yang Mills episode, the hidden premise was a Platonic symmetry smuggled into the standard model. In the mathematical time episode, it was a single word in Newton's definition, mathematical, quietly signaling an idealization that centuries of readers glossed over. Here, the premise we are hunting is not a word Newton wrote, but one he consciously refused to write. Underneath the clean Latin of Hypotheses non Fingo lies a very specific, very dangerous commitment about what gravity really is, and how God relates to space, time, and causation. Leibniz sensed it. That's why he wouldn't let the matter drop. He knew that if he could force Newton, or his defender Clarke, to spell out the cause of gravity in a way that satisfied the demands of mechanical intelligibility, the entire theological scaffolding behind Newton's system would be exposed. Act 1 ends with the dilemma on the table and the silence in place. Gravity is either real or merely mathematical. If real, it seems to require unintelligible action at a distance. If merely mathematical, Newton hasn't truly explained anything. Newton insists it is real, refuses action at a distance, and yet declines to name the cause. In Act 2, we will go into the tower with Newton, into the unpublished manuscripts, the theological notebooks, the alchemical treatises, and look at what he actually believed about space, time, God, and gravity. And once we see that, Hypotheses non Fingo will stop looking like scientific humility and start looking like exactly what it was. A brilliant man, under hostile cross-examination, choosing to remain silent rather than incriminate himself.